on our next video in science, technology, and society. And we're here now in the next video that is, we're going to talk about the nanometer. Okay, so this is our second video in the nano world. So before talking about the nanometer, we're going to talk about the nanoscience and technology. That is nanotechnology. Okay, so nanoscience is a branch of science that deals or studies systems and manipulates matter on an atomic level. Okay, an atomic, molecular, supramolecular. These supramolecular molecular scales means that they are not only small, but they are ultra small on an ultra small scale. So what do we mean by this ultra small scale? We mean here is the nanometer scale. And we're going to talk about that scale in a while. Okay, we're going to talk about that scale in a while. So nanotechnology, we're going to talk about this, the definition of nanotechnology first. So nanotechnology is the study of what happens when things get very, very small. What do we mean by small? So how small is very, very small? Okay, so it is as small as only few matters or only few atoms rather, only a few atoms in size. Okay, so that's when you say you're studying nanotechnology, so you're studying in things which are very, very small in size, that is only a few atoms in size. Okay, this refers to the science, engineering, and technology conducted at the nanoscale. Again, we're going to talk about this scale in a while, which is about 1 to 100 nanometers. Okay, so when you talk about nanotechnology, nanoscience, when you deal with this kind of field, meaning you are dealing with a very, very small field, or a very, very a field which is in a world which is very small, that is only 1 to 100 nanometers. So this employs the study and application of exceptionally small things, okay, in the materials science, in engineering, in physics, in biology, and also in chemistry, okay, and many more. Furthermore, nanotechnology is a very diverse field that is having bigger and bigger impacts on the world. Again, what we want to emphasize is that science is not a static field, so it always improves and improves every minute after one research is done. So every minute, every hour, every day, it improves. Okay, so it has nanotechnology as it was being started. It now has a lot of impacts in the world right now. So it has application where in medicine, in cars, in spacecrafts, food, electronics, materials science, just to name a few among others. Even in some Marvel movies, you will know that Iron Man is now using the nanotechnology in his suit. Okay, so it refers broadly to a field of applied science when you talk about nanotechnology and technology, whose unifying theme is to control of is the control of matter on this molecular, very, very small levels, again smaller than 1 micrometer. So we say, or we mean this by 1 to 100 nanometers as was iterated, and the fabrication of devices within that size range. So how small is a nanometer? So this is how small it is. So we have here nanotechnology. So how big is a nanometer? A nanometer is 10 raised to negative 9. Okay, that is a billionth of a meter. Okay, this is very, very small. You cannot even see things in this size with your naked eyes. So the prefix nano actually means, it's a Greek word which means dwarf. Okay, so this is very, very small. Um, it's a unit of spatial measure. Again, it's 10 raised to 9 meters. Okay, or we can say 1 billionth of a meter. Okay, so for you to imagine um, things in a nanometer scale, imagine this. This is a fun fact. Look at your fingernails right now. Our fingernails are actually, okay, they are actually growing 1 nanometer per second. Okay, so again, our fingernails are growing 1 nanometer per second, in which we cannot see in the naked eyes, but they're growing 1 nanometer per second. So that's how small 1 nanometer is. We cannot see it in the naked eyes. So this is used in nanotechnology. Obviously, okay, from the word itself, it's the building of extremely small machines. So you can see here from the diagram, you can see this symbol right here. This symbol is micro, is the small letter mu. Okay, this is the small letter mu. This is the small letter mu in Greek. This is actually the letter M, so that's why it's called micrometer here. Micrometer. This is 1 centimeter, 1 millimeter, 100. Sorry, 100 micrometers. Um, in 100 micrometers, what you can see is the diameter of the human brain. So the diameter, okay, of the human brain, not the length. When we reach 10 micrometers, what we're looking now is we can see the red blood cells. When we have 1 micrometer, we can see bacteriums already. So where does the nanometers take place, or the nanotechnology take place? It takes place again from 1 to 100 nanometers. So nanotechnology plays its game in between this, sorry, only here. Okay, so this is 100 nanometers. This is 1 nanometer. When you have things in the nanometer scale, what you can see is actually the DNA helix already. Okay, so you can see the DNA helix, the helix of the DNA itself. So you can see that the big we have, this is a micrometer or a micron. Nm is a nanometer, and we can see that's what's smaller than a nanometer is actually 0.1 nanometers is equal to 1 angstrom. So angstrom is even smaller than a nanometer, from a physicist named Angstrom. So let's move on to the nanoscale and nanostructures. So we have here the nanoscale. This is all in 1 nanometer. So you can imagine this is 1 nanometer here. This is sorry, nm. This is 10 nanometers. This is 100 nanometers, and so on. You can imagine the scale. So again, nanotechnology takes place between 1 nanometer to 100 nanometer. So these are the things that we are talking about, or the nanoscale biomolecules that we can see. Okay, when we talk about nanometers, nanotechnology, and stuff. Okay, so water is this. It's still part of our 10 raised to minus 1 nanometers. So it's quite big compared to the universe of the nanometer world. So what we can see here are the DNA. We can see it, like again, in the previous slide we saw that we can see already the DNA helix, the antibodies, the oligonucleotides, the glucose, protein, and viruses. So we can see it here. Even the coronavirus we can see in the nanoscale, or in the nano world. So what are the nanostructures that we can see? We can have the fullerene, the dendrimer, the quantum dot, gold, metal oxide, liposome, and polymer. So these are the nanostructures in the nano world. Even smaller, rather even bigger, rather bigger than the in our scale of the nano world. We can see bacteria and 1,000 nanometers. Bigger than that, we can see cancer cells. Even bigger, of course, we can see them already in the naked eye. So the bigger it is, but our nano world only lies within this range. Okay, so we can see the biomolecules of in the nanoscale, and also the nanostructures. Again, our nano world is from 1 nanometer going to 100 nanometers. Okay, that's our universe in this chapter. Okay, so that's the end for this video. Hopefully you have learned something from the nano world, and there will be the next video is actually the types of microscopes used in the nanoscience and the nanotechnology. So we're going to talk about those in the next video. So thank you very much for watching. I hope that you would like and also subscribe. Okay, so thank you very much.